So this is a very, very long video, but you have to make sure that you watch the whole thing and be pretty happy with that. Otherwise, I might have to give you a massive big slap in your tiny little balls. So very carefully pay attention. Hello, it's time for another plane. You guys like the plane videos, don't you? I have noticed. So the theme for the next plane is going to be endurance, and this came about because I've been flying this gorgeous mini hopper quite a bit in the last few months, and one day I decided to just fly it really nice and gentle, just cruising around, and I thought, I wonder how much flight time I can squeeze out of the battery, which at the time was this one. And so this is a Turnigy Graphene 3S 5200 milliamp hour pack, weighs 360 grams, and flying nice and gently I was able to fly this for 60 minutes, and I thought, that's not too bad. I wonder what I could get out of some lithium-ion packs if I was to use them, because they're a little bit lighter. So we've got 220 grams here. This is a 21700, just a 3 cells, and then we've got a 3S 2P pack here from 18650s, and that's 290 grams. So it's still 75 grams lighter than this, despite having more energy in it. And these are brand new cells. Normally I buy this kind of thing second-hand off Trade Me, but I thought this time I would spend some more money and get some brand new ones and see if they're any better, and they are noticeably better, so I'm quite pleased about that. So this one here I was mainly using on my mini quads. Unfortunately it's not heavy enough to really get the right CG for the mini hopper, but I managed to get, with my 5-inch quad I got 23 minutes, and my 6-inch quad I got 25 minutes, and the farm chopper, that's the 8-inch quad, I got 31 minutes with that, and then this one, the farm chopper, got 36 minutes. So pretty happy with that. Not acrobatic flying, of course, just gentle hovering around mostly. And then when I put this in the mini hopper, we got 76 minutes, and I thought, wow, that's quite impressive considering this plane wasn't really built for endurance. It was supposed to be a bit more of a sporty thing. And I thought to myself, what if I just went all out, only focused on one factor, and rearranged everything towards the goal of endurance? How far, or how long rather, could a plane of approximately this size fly if you put all your effort into endurance? Another thing I decided this plane should have is some LED lighting. Now normally I wouldn't give a shit about this kind of thing, but in this case I think it might be kind of useful, because one problem I had with my mini hopper, the long flight that I didn't time it very well, and I did it sort of towards dusk, and the flight went a bit longer than I thought, and it got very dark, and I couldn't see the plane line of sight at all. So I'll show you a little bit of that here, and you can see what a terribly clutch landing it was. It worked out alright though, didn't break anything. These I found on AliExpress. They are less than $1 for a strip of, I think it's 90 centimeters or something. Decently long, and they're decently bright, and they don't use too much current, so I was quite happy with this discovery. And they're very light, of course. They're very light, get it? So this is what it's going to look like, and yes, I have already been told that it looks a lot like the MQ-9 Reaper. Yes it does. If it ain't broke, don't fix it, I suppose. And I was going to say before, one of the nice things about building your own packs from lithium-ion cells is that you can rearrange them in any configuration you like, and so I thought it might be nice for this plane to keep the frontal area of the fuselage as narrow as possible. So this is barely a 6 centimeter diameter tube, and we're going to stack all of the lithium-ion cells lengthways along inside that. That's the idea. So for this plane, I'm actually thinking to cover most of this in packing tape. So towards that end, the wing sections are very straight. We're not using any of the blended wing style creations that you can do in OpenVSP. It's just plain, straight lines, and I think that'll be good for sticking tape along. I'm kind of running out of fiberglass and resin, and I can't really afford to buy much more of it anyway, so I think I'll go with the tape this time, and the tape's going to be nice and smooth, which should be good for efficiency, I think, and it is also a little bit lighter than the fiberglass as well by the time everything's stuck on there. It's not as strong, of course, but as we discussed before, we're not going for anything but endurance, so this plane could be a fairly flimsy construction, and I wouldn't mind too much as long as I can land it without completely breaking it. So as usual, I started off by designing this in OpenVSP. One thing I realized about OpenVSP though is that with all my other designs so far, I've actually been working with grossly oversized planes. So if I click on the wing here, we'll see the span of the wing here is 1.8 meters, And in the past, I've been working with this number as centimeters, so this would have been 180 for all my other designs. But this time I'm using the correct units of meters, and so all the numbers that I'm getting from the VSP Aero simulator are a lot better. So in the past, all my other planes, that means I was simulating planes of like 180 meter wingspans or something ridiculous like that. And the result of that was that the numbers that I was getting from things like the lift to drag simulation predictions were way off. I was getting numbers like 28 to 30 quite often. But I realized that in the real world that's not realistic. So the actual plane would be somewhere more like about 9, 10, 11 or something like that. But look what happens when you use the correct numbers or the correct sizes. So this is alpha to lift to drag ratio. If I just click on the Y moment, this is pitch moment, you'll see it's 0 at an angle of attack of 0. So it's also quite important for this plane that we want the plane to be flying so that this thin pencil-shaped fuselage is pointing directly into the airflow like that. That's the goal of this. So we want to make sure that the angle of attack is 0 as it's cruising, and at that 0 angle of attack we get a lift to drag ratio of predicted 12.5. So this is probably still a little bit higher than what it's actually going to be in reality, but it's way more realistic than the estimates that I was getting before. Now, since this plane is a fairly simple construction with no splines or curved sections on it, I thought I might also try simulating it in XFLR5. I used this a little bit a few years ago and never really came back to it after that because I like to design the planes in OpenVSP, and more often than not in OpenVSP I'd have sort of curves, or in this section here we can do blending, so you can blend one wing section into another and it makes it nice and curvy. But that's much more difficult to bring into XFLR5, and there's no program that you can use to automatically import it. So you kind of have to set everything up manually, which is why I've never really done it. But I thought this time I would do it because it's just like one airfoil section in the middle, one at the end in each case for each of these wing sections. So it's very easy to recreate in XFLR5. Anyway, I thought I'd give it a try this time. One thing I do like about this though is that once you get all the simulation done, it gives you a pretty nice stability analysis with this nifty little animation like this. So what it does is it starts the model in a perturbed state, an angle, a pitch angle in this case, away from the final resting angle, and then you can animate that to see or to predict what it might behave like as it settles into the steady state, I think it's called. And we also have lateral stability analysis like that. So this is, if I stop the animation, so it's starting at a little bit crooked state instead of pointing straight forwards, and then we can animate that to see what it would do, and hopefully eventually it will settle going straight forward. One pretty neat thing you can get from this is this number here, V, which is predicting the speed that this is going to be cruising at. So 15.9 meters per second is about 57 kilometers an hour, so it's slightly faster than I would like. Maybe about 50 would be nice, but it's okay. Importantly, the alpha, or the angle of attack, is very close to 0, so that's what we expected. These numbers down here, I don't think these are realistic. It's got lift to drag ratio of 106. That's not realistic at all. I'm not quite sure what's up with that one, but it's got all these other specs here. So we've got plane mass. You can see all the point masses here that I've put in for where the battery cells might be. The overall CG is this big blob there in the middle. We've got some tail stuff that weighs this much at that point, and so on. So you can quite nicely set up the rotational inertia, or the body inertia of everything. And it doesn't mention any CG here, but if we look in this panel, we can see the center of mass, or center of gravity, is the X is the front to back dimensions. So it's telling me here that it's 67 millimeters behind the leading edge of the wing, because everything's reference from this this axis here, which is where the leading edge of the wing is, and that's where that big blue blob is there. So 67 millimeters is what we got here. And if we look at OpenVSP, if I just grid this thing here, it's exactly the same. I was going to say it should be pretty much the same. It's exactly the same. Oh shit. Okay, well that's a good sign, isn't it? So these two programs, the science is concurring with the other science, And is it really exactly the same? Well, shit. Yeah, that's a good sign, isn't it? I actually didn't check that before I made the video, but as far as the science is concerned, that's where the CG should be. Now, when it comes to actually building something, we need a proper CAD program, and I like to use Onshape for that. So here's where we set up things like, for example, I've got my templates here for doing some laser cutting. You can see I've just done some slicing and some sketch drawing around those things, for example. And Onshape also lets you do that mass distribution calculation too. So if I click on one of these parts here, or actually let me do this, select all of the parts, and I've given each part either a material. In the case of the wings, for example, I'll say that this wing is made out of a foam that has certain density, and it will use the volume of the wing to figure out what the weight of it is and the center of mass of that piece. And then for other things where I know the weight of them exactly, like the motor, I'll explicitly set a value in grams for those. And then we can click on this little thing down at the bottom where it has this mass and section properties, this little scales icon. And it will say that the total weight of everything is 1.4 kilos. And the center of mass is at that location there, which is the little black and white circle in the middle. And then if we have a look at that here, we can see that it is right on the spar almost, which is where I'd wanted it to be. So that's looking pretty good, and that's with a certain number of cells in a certain position. And we can remove and add things to that selection here. So interestingly, if I click on, so these cells here are my 18650 sections. Each one of these is 3 18650. So if I remove all of those, and there's one up here actually too, we'll see that the total weight of everything other than the batteries is only 368 grams. Now obviously there's a little bit more to it than that, because there's going to be flight controller, FPV camera, FPV transmitter, RC receiver, some LED lights, a few other things. But even with that on there, it's probably going to be 500 grams. I can't really see that it's actually going to be like that, but that's what the prediction is at this point. So it's going to be a very light plane, and that means that approximately 1 kilo possibly could be batteries. So let me, there we go. So this is what I was saying about having the 18650 cells stacked longitudinally. This is probably a bit excessive. I don't think we'll really get to having this many. This is 21 altogether. I'd like to try and get at least 5 sets of these, so 15. That would be nice. The 21 seems just a little bit much, but especially since at the back here we don't really have much room to fit them in. And you'll also notice that going down the middle of this fuselage is a carbon fiber rod, and that's because this fuselage is going to be built in a rather strange way. It's not going to be hollow in the middle, because it's just too narrow to have a wall around it, and it would be very fragile. So it's going to be a solid block of foam with a carbon fiber tube going down the middle, and the cell's going to be slung underneath, strapped to this rod, and wherever I need to put things in, like a GPS or a flight controller or whatever, I'm just going to gouge out a chunk of foam in the appropriate place, stick it in, and then slap some packing tape over the top, and hopefully it's going to hold together like that still. So that's the plan at this point. Alright, enough waffling. Let's see something being made. Alright, have all my templates cut out now from the laser cutter. Very nice and easy when you have one of those, isn't it? And I'm hoping that I can make this plane from this piece of foam here, because that's all I have left of this XPS foam. It's quite thick though. This is a 7.5 centimeter block, so first thing I'm going to do is chop it down the center like that. And most pieces, actually this one might be a little bit big, but most pieces I should be able to get like one on top of the other like that. Alright, well, I have all the large blocks cut out now, and I only used about half of the sheet that I had, so who knows, maybe we can get another plane out of this yet. Anyway, the next thing to do is to split these down the middle like that. Okay, I have all these split in half now. Obviously this thickness still needs to be thick enough to get your pieces out of, so my thickest piece is slightly larger than that and it will fit in there. And so the point of these templates here is the front edge here and the bottom edge here will be aligned with the front and the bottom of the piece of foam, and obviously at the other end as well. So the rib templates go on there like that, and I put some double-sided tape behind that as well to make extra sure that it's not going to slide around. And we have the small one on this side, a larger one on that side, so this is going to be the left wing. You have to make sure that when you use these two same templates next time, you put the other way around. Okay, that's good. Okay, I have all the hot wire cutting done now. Mostly turned out okay. And I was getting a little bit concerned about how thin these tail pieces turned out. They're very soft and floppy. A little bit thinner than I was expecting when I designed them on the computer. The ventral fin also a little bit thin, but that's stronger because it's shorter. So I'm thinking maybe I will put fiberglass on these after all, and this one especially I think I will put fiberglass on that because it has to smash into the ground when you're landing. It has to be quite strong. But I'm not 100% sure about the ones for the tails because I tried putting some packing tape on here. It's nice how it makes it all nice and smooth. And the difference between that and no tape is quite impressive, and I'm going to put a wooden dowel in here as well, so it'll be even stronger than this. But it firmed up quite nicely, and this is with no like spray adhesive under the packing tape either, so the tape will just quite easily peel off. But nonetheless, it has made quite a noticeable difference, so maybe we will just go with packing tape after all. Okay, I sanded off those pieces a little bit, and now we can glue them together using the bottom part of those templates as positioning jig to make sure that we get the twist and the sweep and everything just right. Okay, I glued all the wing pieces together, and I also glued it in the middle as well. Most of my other planes I've glued each side of the wing onto the fuselage separately, but for this one I'm going to build up the wing pretty much completely before I attach it to the fuselage. And the next thing we need to do is put a spar in there, because obviously that is not going to work. Even with packing tape on it, that's not going to be good enough. So we have a spar here that's 8mm carbon tube, and 6mm is going to go in on each side like this. I really like the way these tubes, like, they slot into each other, but they're firm enough that you don't really need to glue them or anything. You just sort of jam it in there and it makes a really good join. And so to get that into the wing, I'm going to use my little hot wire cutting thing. Okay, so that channel is cut now, and the spar sits in there quite nicely because I adjusted the size of the little wire loop for my 8mm and 6mm sections. So next step is to glue that in, but as you can see it doesn't sit in there nice and flat at each end, and that's because this wing is designed so that the whole top surface of it is going to be completely flat in a straight line, but as it sits here at the moment the edges are drooping down so that the bottom surface of the wing is flat. So to glue this in, the easiest way would be to put the glue in and then put the spar in and then tip it upside down and weigh it down against the bench so that the top surface of the wing will be flat. But the problem with that is that the Gorilla Glue will all drip out under gravity. Okay, this is what we're going to do. Put a big piece of wood underneath and another little piece of wood under there to raise it up slightly. And the middle is flat on the bench, and then we have another little bit of padding on the end here so that the bottom surface of the wing is slightly, ever so slightly dihedral, and that makes the top of the wing nice and flat, and that's sitting in there pretty good at each point. And to make sure it's even more perfect, we're going to put this piece of extremely straight aluminium. I'm just going to sit that on top of it while the glue's setting. For the tail fins, they are rather thin and flexy even with the tape on them, so I'm thinking I'm going to put a couple of these barbecue skewers in there in the same way, just groove the channel with the hot wire and use this very convenient perfectly shaped file to make a point on it. So now these skewers fit in here just perfectly. Alright, have those skewers glued in there now, and I'm glad I did that because it stiffens them up really nicely. So since those skewers worked out quite nicely, I put one in the ventral fin as well, and while I still have this thing adjusted for that size, so every time I change the size of tube I have to fiddle with that wire loop there a little bit. But while I have it set up for the skewer size, I think I might put a little bit of that in the wingtip as well, because it's going to be quite strong until it gets to about here, and then it's extremely weak after that. And the problem with where I fly is I'm often landing in long grass on a sloped hillside, and more often than not what happens is the first part of the plane that touches the ground is the wingtip. So a lot of energy goes right into the wingtip, and I can just see this horrible stress riser causing me problems with only packing tape on here. Another reason to do this, by the way, is because we want to avoid something called divergence. Do you know what divergence is, boys and girls? I'll let you look that up in your own time, but we could be susceptible to that for a wing where the torsional strength is not very strong. With fiberglass you can put 45-degree fibers like that and make it nice and torsionally strong, but with packing tape we don't really get the opportunity to do that, so divergence, especially in a wing this thin, could be an issue. Okay, so the fuselage in the design is a 90 centimeter long tube of 6 centimeters diameter, and the foam that I have is 7.5 centimeters thick, so I've cut a couple of squares. It's a nice margin around the outside, and what we need to do with this is put this carbon fiber tube, looks like a 1 meter long tube, but it's actually 2 tubes joined together. So this is 10mm tube, and there's a piece of 8mm tube in the middle that joins them, and we want to put this right down the middle of that. And my original plan was to use my hot wire bandsaw to slice it down the middle and then cut out a groove, half circle on each side, put the carbon fiber in, and then glue them back together. But that would leave me with some ugly hard lumps of glue going down the side for when I want to cut into it. So what I might try is this drill thing, which I've used 1 or 2 times in the past. So that's a 10mm aluminium tube with a 8mm drill bit stuck in the middle of it, and I've been using this as a fireplace poker, so it's a bit filthy. I might have to clean it. Okay, I'm almost done the first one of these, and it's working out quite well. So I just put a bearing on here so that I can hold it nice and tight and push it or pull it one way or the other, because I made a huge mess of the entrance, but after that it was alright. And I'm just using a cordless drill to turn it, and I need another piece of equipment here because once you get about halfway in, it makes an intolerably loud screeching noise at just about any speed, and my ears were having a hard time with that. Oh, cordless drill doesn't like it much either. I think I might have to charge the battery. Well, it looks like we got lucky with that one. It's off by a little bit, but not enough to matter. By the way, the other reason that I didn't want to have a glue seam down the side is because I'm thinking of putting this on a makeshift lathe kind of a thing and turning it, so I wouldn't really want to have a soft area and then a hard area to be trying to turn through that. Okay, I did 2 of these because I actually need 2 of them. This is only 70 centimeters long, so I need another 20 centimeters from somewhere. Second one was not very good, but it's still usable because I can use this bit for the tail where it comes down narrower. And by the end of those 2, my cordless drill pretty much needed the battery charged again, and I can feel where most of the energy went right into this aluminium tube. It's quite warm. Okay, I managed to get that carbon fiber tube all the way down through this fuselage block. It was not easy, but that's a good thing because it's going to be very difficult to get out, which means I don't need to use any glue, so that's nice. So my design called for this fuselage to be tubular, like round. It's not really necessary, I suppose, but I'm going to do that anyway, and I'm going to do it the way that I did for one of my previous planes, which is I used this brushless spindle. It's not really the best thing for this because it's high speed and low torque, but I did manage to get it done with this last time, so I'm going to give it a try again. Made some of the pieces like this on my laser cutter to be the end points or whatever. Okay, we're all set up to do some lathing now, and for those of you who saw my previous video a few years ago where I tried something like this, it didn't really work out too well, so you might be thinking, oh no, not this again. At least that's what I was thinking earlier, but it's much better set up this time. In the previous video I was initially just trying to do it cantilevered from one side with the other end not even being supported at all, and I ended up having to support it with the foam just by jabbing something into the foam at that end, but it still wasn't very good. But on this case we have a solid carbon tube at each end and proper nice laser cut things. This is also mounted much more concentrically, and I can already tell that it's going to go a lot better. Well, that's as slow as it can go, unfortunately, but we're actually already better off than we were last time because it's not shaking itself to bits at this point. And to connect the shafts I went with some precision sellotaping because it's very important that we don't have a run out of more than about 30 microns here. So as I discovered last time I was doing this, the early stages are kind of a huge pain in the ass, so I wouldn't really recommend trying this at home. Not because it's dangerous, but just because it kind of sucks. And the problem is that you're doing an interrupted cut like 4 times per revolution, which is kind of awkward. And if you're using something like this, which is gives you a relatively solid thing to touch it with, it's just going to go donk, 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 donk. And what I've discovered is that what you really want to do is just use a piece of sandpaper like this with attached to nothing and hold it on there like that. And that way, instead of getting individual donk, donk, donk contacts every time, it's a bit smoother because you're actually getting 2 at a time like that, so there's more per revolution contacting it. Okay, well I managed to get it pretty much concentric. Good enough, I think, anyway. You can see as I turn it, it's not quite concentric. Actually, I realized that holding the sandpaper on there like that, you can only do that for so long, because when you do it like that, it's not knocking down the highest point as it goes round. It's just sort of evenly wearing away all sides of it. So that's not quite so useful. So I had to use the donk donk method for quite a bit of it, and also stop every now and then and just use this to like sand up and down like that, where I could see that it was a bit high in some spots. If I turn the motor on now, you'll see it's pretty good. Not perfect, and if we look down here you can see a little bit of shimmering there side to side, but for the purposes of what I'm making here, it's just a fuselage. That's going to be fine. I think my design spec called for a tolerance of 80 micrometers for this, which it looks like that's what it is, so that's perfect. And now I just need to trail off the tail a little bit narrower and put a bit of a round on the nose. Oh no, it's elliptical. How did that happen? Okay, I think we're done here. It turned out okay, but unfortunately it's not as round as I'd hoped. It seems to be kind of elliptical. Like if I turn this, you can see it's narrower there, then it gets wider, narrower and wider like that. And what's weird is the highest parts here, you can see that that's where the sandpaper was scraping. And the highest part on this side and this side wasn't even touched, despite it being the highest part. How in the world, how does that work? It's just wearing down the lower part more and more all the time. So I guess that must be some sort of resonance with the frequency that it was turning, and maybe I was just sort of bouncing a little bit. But for the last part of it, I was holding this file, and I can get quite a strong press on the bench like that, and then just gradually lean it in, and that should hit the highest part first, right? But it didn't seem to be doing that somehow. Very strange. But anyway, the narrowest part is the size that I want, so I'm going to stop there. So hopefully you can see there that it's not quite round, it's more elliptical. But apart from that, it looks quite nice, so I'm just going to pretend that that's what I wanted. So at the current time, with just the raw foam and everything for the wing and the fuselage and the tail pieces, we're looking at 280 grams. That's not bad. Just doing a little temperature check here to see that nothing gets crazy hot with my infrared camera thingy. The hottest point here was like 40 degrees on one of these. 42, 41. But that's barely above skin temperature, so that's fine. Actually, mainly what I wanted to check here was my little MOSFET board. Make sure that's not getting too hot. That's fine. What's that? 19 degrees. No problem. And that's with 12.4 volts and 1.5 amps. It's 18 watts when they're all going like that. So I wasn't really expecting it to get too hot. I mean, there's not not that much power going into it. Looks nice though, doesn't it? And of course I'm going to use my little hot wire cutting thingy here to make the groove for these LED light strips. I've adjusted it to the correct size, 5mm by 2mm, and we can cut out a nice little sliver of just the right size and shape like that. And when you put the LEDs in there and a bit of tape on top, the tape goes perfectly nice and flat over the top of the LEDs. Isn't that nice? Well, I figured out how to set up a relay output on ArduPilot. It's interesting that there's a kind of a delay. Like, it's not what I would have expected. To mount the motor, what I quite often do is use these aluminium mounts that you get with some motors when you buy them. They're nice and light and convenient, and the way they work is you screw the motor on, or screw that onto the motor from the back of the motor, and then it will go onto a piece of wood, and you can place, well, the motor will be stuck on there like that, right? And then this is convenient because you can get at it from the front to screw it down or unscrew it like this. But what I don't like so much about this is that it kind of forces you to use a piece of wood or carbon fiber or whatever you've got behind this cross piece has to be at least as big as the cross piece. So you're going to end up with a piece roughly that big, maybe a little bit smaller would be good enough. But it's kind of about that size. But for this plane I wanted to make it as small as I could, or actually not as small as I could, but just a little bit bigger than the motor. So it's going to be like that. That's the size I wanted, but that doesn't really fit very well with this thing. So I came up with a different plan of attack, and it's based on, or it's making use of the fact that we have a carbon fiber tube sticking out the middle of the fuselage there. So it's going to be something like that. And the reason I have this other plate in the middle, by the way, is because I need to have an 8mm tube here that glues into something, but I can't really glue it into the front plate, or the larger plate here, because on this side I need to have a little bit of a recess that's 10mm diameter, in other words larger than that tube, right? And that's so that this little bit that sticks out here in the C-clip is not going to collide with anything. So that's why I've ended up with this separate piece in there, and so then you'll be able to get to the back of this to screw the motor in from here. Here are the motor mount pieces ready for gluing, so I just cut these out on my CNC machine. Okay, so that's all glued up there and looks quite nice. A little bit of a cavity here so that the lumps on the inside can fit in there. It's still quite easy for it to turn like this, so I might have to put a little bit of Yoo-hoo pour behind it just to stop that. Not too much though, because I want to be able to remove this later. And another thing I'll do obviously is when these wires go on here, I'll fix these wires here so that worst case, even if the plate starts turning, the wires will stop the motor or stop the plate from really turning too much. Usually when I make a plane I build the two wings separately first and then stick them onto the fuselage. But for this one, as you've already seen, I'm building up the entire wing completely all together first, and I'm going to try and slot it into the fuselage into a gap that I'm going to make with hot wire. And so that's what this is for. It's a guide for the hot wire cutting, and the fuselage goes in there. This step is also where the angle of incidence between the tail and the wing is defined, so we have to be a little bit careful here to, like, you know, get it right. Alright, that turned out pretty nice. The top of the wing and the top of the fuselage is supposed to be at the same height, which is pretty much what we got. I guess there's no hurry to get out and fly. It's going to be like this all week apparently. I decided to completely fiberglass the ventral fin because this is going to be hitting the ground over and over, and it's only a small job, so it won't be too much trouble. So I put some lightweight putty in here just to fill that gap so that the fiberglass can sit over the top of it nicely. The nice thing about the tape, if you're using packing tape for covering, you don't really need to fill that gap because the tape will naturally just sit over the top of it nice and flat. Well, it's time to do something about the hinges on the wing and the tail, and my original plan for this when I was designing the plane was to make these out of tape, just packing tape. And I took a look at Home Slice 1, which I made years and years ago using just packing tape for hinges, and it's actually holding up quite well. I was surprised. So it might have been okay to do that for this too, but because the Home Slice 1 wing is thick, I was able to put a piece of little carbon fiber strip in it to keep it strong, and that was fine. But here the wings and the tail pieces especially are just too thin, so we're not going to be able to do that. So what I'm going to do is I'm just going to use the old peel ply hinge method, and I think I'll put also a piece of glass over the top and a piece of glass on both sides of just the bit that's going to turn, the actual control surface itself, and that will keep everything nice and strong, and it will stop the control surface from bending too much, and it will also contribute slightly to the flexiness, or the reducing the flexiness of these tail pieces. Another nice side effect of having fiberglass on the trailing edge is you get a little bit of surface area for free along the edge like that. So you can see the foam stops, but we get a few more millimeters. Actually looks like about almost 8 millimeters there in this case of surface area, and so that's, you know, a little bit more, a little bit less wing loading, and it also keeps it strong. So I could probably hit this quite hard before it starts to break. Here's Home Slice 1 in all its glory. It's a blast from the past, isn't it? And this is what I was saying about these hinges here. On the underside there's a 1x3 strip of carbon fiber which holds it quite strong, but as far as the tape goes, looks pretty good actually. So this was just regular packing tape. I'm kind of surprised it held up so well. I probably put 2 thicknesses of it on, perhaps. But to do this, you kind of have to cut the aileron out completely and then stick it back in, so it's never going to quite get in the same place. This one's really good actually, but you can see it's sticking up a bit there, and this one in particular here, it just gets kind of lumpy and you can't quite get it exactly where it's supposed to be. But if you do the peel ply method, then you don't have this problem, because the peel ply is going to hold the piece exactly where it was to begin with. One of the most tedious parts of fiberglassing is getting all the pieces ready. But anyway, so that's what's going on the ventral fin, the tail pieces, and the wings. So this is how you get that extra little bit of surface area on the back. You just make sure that both sides of the trailing edge are nice and wet, and they're sticking to each other along the full length of it. I made this little jig to try and keep all the battery packs consistent, the same size and spacing and everything. Well, I decided to put fiberglass all the way down the trailing edge here actually, all the way along there instead of just around the ailerons. And there's quite a few reasons to do that. One is that now it's quite robust and I don't have to worry about banging it on things like that. Another reason is that now I have a second chance to make the trailing edge nice and straight, because I haven't cut it there obviously, it's it's still rough, but when I cut it I'll be able to get it nice and straight and nice and symmetrical on both sides. Another reason is that because the wing is made up from separate pieces of foam, because these were cut in different hot wire cuts, and this wing is quite thin, so there's only a little bit of Gorilla Glue holding the two pieces together. So bridging them across with fiberglass like that will make it much stronger, and the wing rigidity overall will be better. And in the case of this particular wing, another reason to put fiberglass on the trailing edge is that this wing has a little bit of reflex, or like the tip of trailing edge is like going down a little bit. I don't know if you can see that there. You can maybe see it a little bit better on that. And the angle of incidence here looks pretty flat. So I was kind of concerned that if I didn't manage to lock in this reflex there at the trailing edge, and I figured that packing tape would be a little bit soft given how thin it is, then this airfoil might not actually perform the way the science said it should. So that's why I wanted to make it rigid at the trailing edge like that. By the way, you can see I've got a little bit of a wire around the carbon fiber tube in there. So the idea with that is it's going to be wrapped around here to make sure that the spar and that spar are like clamped together nice and properly. Otherwise, just this glue joint here would be the only thing that's holding the wing to the fuselage. So after adding the fiberglass, we're at a total weight of 350 grams for all of the airframe parts now. Although we should probably call that 330 something because I've got the two tail servos are in there now, so I'd say it's probably more like about 338. I had a question or two recently about how these peel ply hinges are made. There's nothing to it really. You just stick peel ply on over where the hinge is going to go, so you can see this bit with the red lines in it, that's where the peel ply is. And then underneath that you need to just make a mark and then cut carefully, so on the opposite side to where the hinge is going to be. You just cut through the foam here, but not so far as you get to the other side, because you don't want to cut through the peel ply. And you only need to cut about halfway through, and then you can probably just start bending it like that, and you'll feel the rest of it breaking away. But you don't want to bend it too much straight away, because on the other side you want to make sure that there's a score line so that the hinge will show up exactly where you want it. And to do that, I just use the back of the knife, so not like that, I just use it like that. So there's a little bit of a sharp edge on here, but it's not going to cut right through much. And that's just to break the fiberglass that's on top of the peel ply. So I put the peel ply down and then one layer of fiberglass over the top to make sure it sticks down, because peel ply, if it's peel ply only, it can tend to peel up, so you probably want to put fiberglass over top. Oh, I should mention I've already cut this bit here using a scroll saw, but you could use a coping saw or something to cut these bits there as well. And then with a bit of luck you can just break the foam on the back side, and then it will bend exactly where you told it to with this score line. And then you just need to go like this a whole lot, and when you can get it back to about this far without too much force, about that far, then you just need to trim off this wedge here so that when it goes down, it can go down the other way as well. So I usually do that with sandpaper, but you could do it with a knife, I suppose. So for the servos, I'm going to go with these rather small ones. I think these are 5 grams. Metal gear for the tail, because that's slightly more important, and plastic gear for the wings, because if one of these fails, hopefully the wing will still be able to be leveled by the other one. I'm not super confident in these actually, because I've had one of those fail in the past. I think actually 2 of those failed on me, so fingers crossed that these ones hold up okay. And the reason I'm going with these small ones is I just wanted to keep everything light and compact, especially for this. Ideally I wanted to make it so that it didn't jab out the other side, so I managed to do that. And as for the positioning of where they should go, whenever I sit down to do this, I always think to myself the most important question, which is, what would Davids do? Unfortunately, no matter how hard I rack my brains, I always seem to get it in the wrong place still. I noticed that the SpeedyBee F405 Wing Mini has 2 inputs for analog video cameras, and it lets you switch between them by well, you can set it up to do it on your radio, which is what I've done here. And it's actually quite easy. It switches the same way, it's basically the same as I was doing for the LEDs. So I've got a Cadex Ratel there and a no-name FPV camera there. And over here, if I switch the switch on my radio, you can see we switch between those 2 cameras. That's pretty nice, isn't it? Just trying another little experiment here. So we have this camera on there, and when I flip the switch on the radio, this time we get, oh, it's my Raspberry Pi over here. Now why would we want our Raspberry Pi display showing up on the FPV screen? Well, you'll just have to wait and see, won't you?
together, traveling the country, doing actually events like the one he was doing today. Intense, on college campuses. And it makes you think about, what did he do that was so wrong that earned him this fate? It was to foster open conversations with young people who were hungry to figure out what they believed. And that's what he did. And I think more than anybody else I know, I really mean it when I say this, I think more than anybody else I know, he was committed to talking to people who disagreed with him. To do it openly, that was his ultimate sin.
Just experimenting with a few ESCs to see which one might be the most suitable. And the main thing is that we want it to keep turning the motor even when the battery gets very, very low, lower than LiPo battery levels. And I found that this AM32 ESC here, it's one of the ones that Pete from Alka Motors gave me, but I noticed that it goes all the way down to 6 volts. So if I change this, I'm at 12.4 volts there, right? But I can change that by 1 volt at a time. You spin the motor up and turn this down now. You turn it all the way down to 6.4 volts. The motor's still spinning. Can we go further? No. Okay. I'll just turn the throttle down before I turn it back up here. Alright, but that's good to know. So even at 6.4 volts the motor's not going to stop. It also seems to be braked by default, which is quite handy. Alright, so this doesn't go on, but I think it's close enough that hitting it with a hammer will get it on, right? And when I say get it on, really get it stuck on. So that's kind of what I'm going for. Whoa, there we go. Perfect. Looks like some of these props actually have quite a bit of vibration at higher throttle ranges. I'm not sure if it's because I'm just, it's not very solidly mounted, it's just on this little tube, right? But also they're not balanced properly, I guess, and I think that's okay though. I'm not going to bother with that too much because we're not going to be running at high throttle much, just for the launch only, and then after that we're probably just going to be like, probably about like that. I want to cut most of the bottom of the fuselage away to make a battery bay, so I'm going to do that with hot wire, but I don't want to go too far in and hit the carbon fibre spar in the middle, so I've used a couple of thin strips of aluminium, one on each side there, to like block that off so that my hot wire can slide along here nice and smooth. And it's going to be enough for 7 of these to go nose to tail. Yeah. Okay, I went a bit crazy with the hot wire cutting things off, so this large piece is for the batteries that came off the bottom. Obviously there's not enough room for the batteries still, so I'll have to make a nice groove, or a couple of grooves down the bottom so that the cells can actually fit in. I also took a piece off here. This is where the flight controller is going to go, so we need a decent sized area with a nice flat section for the flight controller to sit on. Also chopped off the nose, going to put the camera and the video transmitter up there. And as much as it pained me to do so, I also cut off this bit, which was the, like, for the trailing edge of the wing, like that. It was beautifully done, but I realized that if I'm going to slide the wing in there to glue it, I'd have to put a bunch of glue on this side and then slide it in that way, and the glue wouldn't really go where I want it to go. So instead of doing that, we're just going to chop that off and put the wing in there, under there like that, to glue it down, and I'll just have to glue this back in separately. So for these other pieces, I'm thinking to cover them with fiberglass, and then when the fiberglass is cured, I'll remove either some or all of the foam from the inside, and then they should have a nice cavity underneath them to go back on top. Not quite sure how I'll mount them in there again yet, but we'll figure something out. Alright, I have those pieces cleaned up now and sitting in there nicely. The fact that this bottom edge is flat was convenient because it let me stick it onto a piece of wood to make extra sure that it wasn't going to twist or warp while the resin was curing. Unfortunately now though, it seems to become very heavy for some reasons. Oh, right. So we have 21 cells in there now, and I was able to fit them in by making some grooves with my hot wire tool, resizing that little loop on it yet again to match the 18650 size, and I used this temporary, dummy pack. Made that with my template to get things in the right size, and that let me put the grooves along the bottom in the right place as well. There's precious little foam surrounding this spar now, but don't worry, I did plan ahead, so hopefully it's going to be okay. I'll still need to trim out a little bit here because we're going to have some wiring in here and some XT30 connectors, so it might not fit quite as nicely as it does right now, but for now, happy with that. So this amount of batteries, as I said at the beginning of the video, I don't really see this being feasible to fly. This is 1,050 grams, so it might be alright. It might be a little bit tricky to launch, but once it's up, it'll be okay. Perhaps it'll be something like that. But I have to keep reminding myself that even though it feels really heavy, if we get to this point, this is going to be 2/3 of the overall weight of the entire plane. So maybe it's not as bad as it feels when I pick it up like this now. So anyway, I'm going to make up a bunch of packs like this, but not in 1P configuration like that. I'll make a 2P pack that'll be like the minimum pack that we start with, and then I'll make up a 3P and a 4P, and between those I should be able to get every combination of 2 through to 7 just by combining those packs together. Oh, and I should also mention that this little hatch here is not supposed to be doing the job of holding the cells in. This is just for aerodynamic reasons. To hold the cells in, I'm going to have a little bit of something, maybe even one of these barbecue skewers perhaps, and that's going to go alongside the cells here, like one on each side, and then around the spar there'll be like a strap holding the cells to the spar directly. So don't worry about this being flimsy, that's okay. Now this electronics hatch didn't really work out so well. Well, actually the hatch itself is beautiful. I really like it. So a little bit more hot wiring and sanding, and we have a nice 3, maybe 4mm section of foam left. It's actually quite strong still. I really like it. So I want to keep it like that, but it doesn't actually fit over the flight controller now. It's a little bit off, so I could either remove that foam, but I don't want to. So I think what I might do actually is, these flight controllers are connected, there's 2 boards. The board at the top is just for power distribution and power regulation and current sensor and everything. And the accelerometer and all the other stuff is on the main board in the middle. And they're connected by this plug that goes between them there. Whoop. Oops. But what you can do, what I might try, is just separating them, and this front bit or this top bit will be folded over, and that will let me make it a whole lot lower, and using tiny little bits of wires instead of that plug, and so the whole thing will actually fit quite nicely under this cover then, and the layout will be more convenient for me as well. So the nose was done the same kind of way, using my hot wire tools to gouge out a bunch of stuff from the inside of it, leaving a little bit of foam. That seems to make things quite strong actually. Just a little bit of fiberglass and then a little bit of foam together is really good. So I used yet another tool that I made up here, a magic wand with a little loop on the end. You have to be careful where you're holding this though, otherwise it might work its magic on your fingers, I found out a couple of times. So then the video transmitter I'm thinking to put in here as well. Unfortunately it won't quite fit in there front to back like that. So what I'm thinking is maybe to gouge out a bunch of foam in the same size as the antenna and shove the antenna in here like that. That's not really ideal either because it's quite close to the carbon fiber spar, which is right there. But I'm trying to keep everything out of the airflow, that's what I'm thinking. And I don't really want this part of the VTX to be embedded in foam because these get quite warm and the foam would only make that worse. But if I was to do that, it would be inside this empty cavity with air around it. And I can make a little hole here so that some air was actually getting into it, I suppose. If that doesn't really work out, what I could do is just make a hole in the top of this and have the antenna sticking out a little bit more traditional manner. It'll be sticking out in the airflow like that. In an effort to keep all the bits and pieces out of the airflow, I've been making a whole bunch of gouges for the wiring to go inside instead of sticking outside. And you're thinking, how's he going to do that when there's precious little of this fuselage left already? Well, just you watch. So we start at the back here. The tail is going to stick on here, and I'm thinking to only have just one ground and 5 volts, and then a separate ground and 12 volts for the ESC, and then just the signal wires only. So we don't need 9 wires to do the ESC and the servos. We just need 6 for everything. Anyway, so that's going to go in here, and then around about here it splits into 2, and that matches up with some gouges on the bottom of here because that's going to go on there. And so that brings it forward a little bit, and then we get to the top of the wing, which is here. So it's going to transition into here, and then it goes through the wing after being joined by the aileron cables there, and then it comes through the bottom of the wing. So that's the front of the plane. This is the leading edge here, and so it comes along here. And the reason it splits into 2 is because we're going to have the fuselage spar under there, and I'm going to tie that together with some soft wire to make sure that the fuselage spar and the wing spar are held together very securely, because that's how everything needs to hold together with this piece of wire. So that's why it splits into 2, and then we come to here and we're joined by the LED wires, and that comes into everything at the leading edge of the wing, and then we're back into the fuselage. So there's a gap where the leading edge goes, and that's going to come out here, and that's where the flight controller is, and everything's going to plug into the flight controller there. Well, not plug in, solder in. So I just stuck the tail pieces on with some double-sided tape for now, and this is what it's going to look like. And this is just with the airframe parts only. Oh, and the servos are in there. And we have 389 grams, like that. And then with everything it's going to need to fly, so that's including the motor, 10-inch prop, the LEDs, everything except for an XT30 connector somewhere. We're looking at 564, which is pretty good. Oh, but we need the packing tape, right? Packing tape and fiberglass tape has to go on after that. So it'll be probably somewhere around 600 grams. That would be nice, wouldn't it? It's still pretty good. Okay, I'm getting ready to put some tape over the wing now, and I had to embed a couple of things in the wing. I wasn't sure where these were going to go originally, but this is where they've ended up. So we've got the GPS over here, that's all nice and flat. The receiver with some antennas in here. After the tape goes on, I'm going to take this one, I'm going to cut that one out and stand it up vertically so that it's about here. This one's going to remain flat down horizontal. I just don't want it to be sticking up while I put the tape on, obviously, because then I'll have to get the tape going around it somehow. The receiver is a FlySky FSIA 6B, which is normally that size, much larger. So I've of course taken the little case off it, and I even went as far as taking this vertical PCB off it as well. So see all those pins there, they're actually on a separate second PCB that's soldered vertically to the back of it. So I took that off, and now it has become rather small, and I had to figure out what all these pins were on here too as I was doing that. So I'll put a little diagram on the screen for myself for future reference if I did this again, and also for other people might be useful. And so I'm going to glue this into the fuselage, and then I've made these holes here much larger than they were before, going all the way through the bottom. I'll show you that in a minute. And the reason I did that is because I realized I'm probably going to want to poke wires through from the back after it's glued on, and if these holes are not nice and large and there's like a clear space to get through, that would probably give you a headache, wouldn't it? So this is the bottom of the wing, and we've got the LED strips in like that. I used Yoo-Hoo Paw just to tack these down a little bit every now and then, and also to make sure these wires kind of sit there nicely instead of getting in my way while I'm trying to do things. And these two servo cables from the aileron servos, to make sure they don't get in the way when I'm sticking wires in from the back for the tail stuff, I actually Yoo-Hoo Paw stuck those down to the roof, or so this is the bottom of the wing, so that's the top of the cavity there, and so they're actually glued in where they are now. And then we've got going to have a whole bunch of wires coming out this little gap here. I didn't want the inside of this channel to be sticky, and it has to keep the glue out when we put the wing into the fuselage. So I put a piece of packing tape upside down, and then another one the right way up, and a little bit of Yoo-Hoo Paw around to make sure they don't go anywhere. So the inside of the channel now has the smooth surface of the packing tape on it, and that makes it so that we can put a piece of wire in from this side. It nice and easily slides through like that. Starting to look pretty tight here, but I think we're still okay. Before I glue the wing in, I thought I might just check that GPS because it's a brand new one. And I'm glad I did, because after 30 minutes, it's only getting 6 satellites, so it seems like something's wrong with it. It's not tuned very well, and it has no excuse because it's sitting out there in the middle of the lawn. It has a perfectly clear view of the sky. The GPS is one of these Rush FPV ones, and it's the second one I have. The first one here is in the mini hopper, and it's been working exceptionally well so far, so that's why I bought the second one. But I might have to swap this one in instead, because you don't want to have a GPS that doesn't work in your plane, do you? So I just went out and plugged that other GPS in, and within about 25 seconds we already have 7 satellites, and 9 now after about 35 seconds. So it's completely different. 10, still less than a minute and we have 10. Admittedly, that one was used about a week ago, so it's not a cold start of a brand new unit, but still. Actually, I was just about to swap the wires over on these two GPS modules, and I noticed that the little nicks that they have out of the side of them on the patch on the top, you can see there's one on the left and the top edge, as they quite often seem to have. There's another one over there with a couple of little nicks over it, and I think Uncle Bruce told me that this is some kind of tuning that they do to improve the reception. But this one over here on the right, so this is the one that wasn't working very well. It has one nick on the left edge, and then on the top towards the edge, just above the W, there's a little mark where it looks like it's been touched by something, but it hasn't actually been cut through. So I'm just wondering if maybe that was supposed to be a nick on the top there, and I thought I might as well make a little cut there myself and see if that improves anything. Well, what do you know, it looks like that actually did help. So we've gone from never seeing more than 6 to seeing about 11 to 12 pretty steadily. And I tested the other module again just now in the same conditions, so it's a few hours later now, it's almost dark, and that one was getting 14 to 15 satellites, you know, with the satellites in the same positions as they are now. So it's still not as good as the good one is, but 11 or 12 here is perfectly good enough to put on the plane and fly it, I think. By the way, I don't know what kind of material I've made this patch out of, but it was extremely difficult to cut through. In the past, I've managed to damage these BN220 modules just by sticking some sellotape on top and then pulling the sellotape off, and that silvery stuff pulled off with the sellotape as if it was just some kind of fragile aluminium foil or something. So I was expecting it to just cut nice and easily, but I couldn't cut it with this knife, and I couldn't cut it with the tip of this file, I had to resort to a carbide end mill and use the edge of that to cut it with. It was so difficult. What did they make this stuff out of? Okay, now that this area is all nicely tidied up, it is finally time to do a massive big slap of tape on the surface of the wing. And I'm going to start by doing this with fiber tape here. Not for the whole surface, just for the parts that I feel need to be the strongest. And I didn't really plan on buying this actually. I was thinking to go just with plain packing tape everywhere, but I noticed this on AliExpress. It was less than $1, so I threw it into my shopping cart, and I'm glad that I did, because for one thing, it's quite smooth. I didn't think it would be this smooth. I thought maybe these fibers would cause a little bit of bumpiness there, but they don't. And it's also obnoxiously sticky, which is why I've left that plastic film on the side, because if you put it down on something, it gets stuck to whatever you put it on. So that's really nice, and I think this tape would be sticky enough to do without any spray adhesive underneath it. Unfortunately, the regular packing tape is not, so I'm going to stick that down with some of this ADOS spray adhesive. I actually bought this 3M77 here to do that with. I heard about this on RC groups years and years ago, so I looked into it, but I couldn't find any in New Zealand at the time. But since I'm doing a whole lot of this now, I thought I'd check again, and I found that Bunnings does stock it now. Unfortunately, they don't ship it though, so I had to make a special trip in to get that. Over an hour of driving, only to bring it home and find out that it says, not suitable for bonding polystyrene foam. What? So I guess all those people in RC groups must be using this for something else. See how it says, what does it say? Contains acetone. And I did a little check, did a few tests, and sure enough it's not going to be suitable for polystyrene, so I'm going to have to go with this one. This works pretty well. It's just getting a little bit low, so yeah, hopefully there's enough in there. But I know that this one's fine on polystyrene. Oh shit. Ugh. So we're coming down to here. It's kind of a two-person job, this. Just a little tip for new players: if you do happen to buy some of this tape, it comes with this film, as I said, to stop it from sticking to everything. You might actually want to take this film off before you start using it, because what I found about halfway through my roll of tape is that one side of the tape was, because it's so sticky, it was sticking to this like film on the side, and as I went round, every now and then one of the strands of glass would get stuck to the side, and the piece of tape that I was pulling off to use on my plane was becoming narrower and narrower. And so you can see now I've gone about sort of 15 to 20 revolutions around this tape, losing those strands on the side, and they're just stuck to this horrible mess of like the backing plastic, and they were wasted, so don't do that. Okay, so the wing is all covered with tape now. Unfortunately, I think that added about 50 grams, so that's not great, but it does make it a bit stronger and smoother and everything. And now I'm gluing the tail pieces on, and they're being glued on with Gorilla Glue and 5-minute epoxy. The 5-minute epoxy is just for the bottom of the spar here, so I scratched up the carbon fiber tube that's going down the middle. I scratched it up here, I mean, so that it should have something to bond the epoxy to a little bit better. And I just put epoxy on the tip of this, so the idea is that this little spar is connected to the little spar inside the fuselage, and then on here I just put Gorilla Glue all the way down there for the rest of the join, and I made a little plywood piece to get my angle correct. Okay, I've glued the tail pieces on there now. It's looking quite nice. They're just tacked on with Gorilla Glue, and next step is to make a little fillet with microspheres and fiberglass like in here. And unfortunately it's not going to be as strong as the other planes that I've made, because this is just bare foam here at the moment, and normally the fuselage would be skinned with fiberglass, so I'd be making a fiberglass to fiberglass connection with my fillet, but didn't really have enough resin to do that, so the last few drops of resin that I have are going to be used to make this fillet. I made a Patreon, by the way, recently. If you want to help me out with that kind of thing, I'll put a link in the description. So we're going to put these little bits of glass on there, and we're going to be using these microspheres, which looks like a powder, but apparently this is actually tiny little balls, or spheres I suppose, because it's hollow. The point being it's going to be very light, and yes, so that's where the last of my resin is going to go. And if I have enough of that microsphere mixture left over, I'm also going to put some in the nose cone thingy here and squash this FPV camera in, covered with packing tape and plastic wrap, of course, so it doesn't get stuck in. So I'm hoping that we'll just make a nice little seat for it to slot into, and I'll be able to pull it out later on. If it does happen to get permanently glued in there, I'm not too worried about that, but we'll try for the not permanent case first. Wow. There it is. All this like plastic wrap on it, it's kind of making it difficult to see. Yeah, I don't know if that was such a good idea or not. My plan was, of course, that as I was pushing this camera forwards, I would very carefully pay attention to the way that the camera was facing, but I didn't consider that with all this gunk over it, I can't see it very well. So it has a piece of paper over the lens, and then some sellotape, and then some plastic wrap over that. Alright, well I think I'll leave it there for this video. It's gotten pretty long. You can see that the plane is taken shape pretty well. We're almost done actually. We just have to glue in the flight controller and do a bit of soldering onto that and make some control linkage thingies, and then I'm going to have to glue the base of this motor in as well, I think, to stop it from twisting. But before I do that, I want to do a bunch of testing with these props. I made quite a few of these prop adapters, and I want to test, you know, how much thrust we get at various current settings for those. So I want to do that with a mount rather than sticking in the plane and having to test it on the plane. So I'll do all that off camera sometime. And the weight of the plane and everything here at the moment is just under 500 grams. So that's without the motor and the flight controller and the VTX, and also the hatch on the bottom is not on there either. So when all that goes on, I think unfortunately it's going to be over 600 grams, which is over my goal, as it always seems to turn out, doesn't it? You never quite meet your goals with this plane stuff, do you? But anyway, thanks for watching. In the next video, we'll probably have this flying, so see you next time.